okay, let's take a look at the next thing. We looked at storage. That's kind of like saying, I've got a big field that I want to plant stuff in, but now we got to do something with it so I can actually do the planting, do the thing that will make it so I can use it. And that's file systems. So we're going to take a look at what a file system is and the features that file systems have. And there's plenty out there. Not too many to confuse you, but there's plenty out there. So yeah, files are things that we store. Right? They're a set of ones and zeros, and we got a lot of different kinds of file types. For instance, is it an executable file or a document or an Excel spreadsheet or video or a picture? Those are all different file types. And we store those on hard disks and flash drives and CDs and DVDs and all that. It's just basically a bunch of ones and zeros, and it's got a little flag that says, I'm this file. That's really what it has on it. And they say groups and organized together, and really they're not. They're spread all over the place. But they'll have that little flag that'll say, I'm this Word document. I'm part 2 of that Word document. I'm part 3 of that Word document. Now we deal with file formats. Well, while it's possible for a file's data to be completely arbitrary, which it can be, most are organized in some way using, an image file, for example, as I said. Files usually have this stuff and this stuff. Metadata is the data that describes what the file is. That's the best way to put it. So inside of this ones and zeros, and it's all over the place out there, and it's got the little flags that say I'm part of this file. There's metadata that actually say when Word loads me, I'll be able to do this because I'm a Word file, or when I'm clicked on, I'm a picture, and they'll be able to see all the pixel data and everything on there, right? So the metadata is what really is describing, this is what I am. This is what I can do. So the file system or the operating system will know, okay, that's what makes you up. For instance, you have file extensions, and they're not like hair extensions, so don't think of that. Common Windows file extensions. Oh, I'm sure I've got that spelled wrong, but let's just take a look. That's right off of Microsoft support. And there's some file extensions there, and this is what they mean. There's an AVI file. There's a bin file. If we look through here, we'll see GIF and JPEG. And basically, these 3-letter extensions actually tell it, this is what I am. But that doesn't mean if you change the extension at the end that it becomes a JPEG. You can't take a music file and then go, I'll make it a .jpg and see what the music file looks like. That's not the way it works. When you try to launch it, of course, the video reader or the picture reader is going to go, I can't read this. Right? This metadata is all wrong, and the data is not matching what it's supposed to be. So changing the extension doesn't go anywhere. This metadata is really important for the actual file. And those file extensions is what we're just looking at. That's a way for the operating system to go, oh, you're a picture. Real quickly, I know you're a picture. When it lacks the file extension, it doesn't mean that the data is corrupted. It doesn't mean that it's not a picture anymore, or not a music file or a video file. It just means that the computer doesn't know what to do with it. And so you just add the extension on there, and it'll try to load it correctly. For instance, grandma might send you a Word document, but she deleted the extension, and it's My Famous Recipes. You can still go into Word, find the file, and Word will open it because everything is set correctly. Now, file systems, that's the way we're actually going to keep track of what's going on. That is how we basically organize all these ones and zeros that are all over this device. Let's say it's a hard disk. All over the platter is all these ones and zeros. So how can I interact with that as a human in some way that makes sense to me? Well, the file system will construct things and give names to things so that we can keep track of, this is a folder and it's got 5,000 other folders in it, and it's got 5,000 files within each of the 5,000 folders, right? There's some way that we can look at it and figure it out. And so when we say the term directory, that means folder. So when we talk about file systems, we'll often say directory. And that's the old term that we use for going to that directory. In other words, it was kind of like saying, go and look at this particular file that'll have the information about what's in here. Now we usually see them as folders, and so we tend to call them folders. Now, one thing is that we use a hierarchical file system, meaning we can say folder, subfolder, 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 file, 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 file. We can have it hierarchical, which really in our reality, we don't really do that with files. We put files into folders and put folders into cabinets. And that's the way we do things. This would be like saying, I put a file in a file, and I put that file inside another file, and I put that file, and then I put, yeah, so there you go. On Windows, the / is the root directory. So when we look at a location for this particular file, it's saying it's off the root directory in the users folder or directory, in the documents folder, AKA directory, and then you'll find that. That's where that's located at. This is a very common thing to see. Now in Linux, these are not /, they are /. And I'll have students tell me all the time, well, why is this a /? Well, it's leaning backwards. A / leans forward. And when you haven't really dealt with this kind of thing, that is a complicated thing for most students. They'll often be typing a command in Windows, and they'll go, this isn't working. And I'll go over and look, and I'll go, oh, those are /. And they'll be like, what? Yeah, the slashes you put in are /. If this was Linux, it would work. If it was Unix, it would work. You need to use / because you're in Windows. You're on a Microsoft machine. So remember, just remember that /s lean backwards. That's why they're called /. You're not telling it to go backwards. You're describing how this slash leans. It leans backwards. So specific file systems then that we can create these files in this hierarchical folder structure or hierarchical directory structure or hierarchical file system. It's a way of saying that. Are FAT32. FAT32 stands for File Allocation Table, and it's 32-bit. The first version of FAT, I think, was 12-bit or 8. File allocation. They just called it FAT back then. These days, if you see something that's just FAT, it's formatted just FAT, it's FAT16. FAT32 is 32-bit. And exFAT, these are not EX, these are EXTs. exFAT, I don't know why that's not listed here, is 64-bit FAT. Okay, so the main thing that you need to understand with all of the FATs, right? FAT, FAT32, exFAT, not FAT64. They should have called it FAT64. Those are all cross-platform. Linux, Unix, Mac OS, which is Unix, Windows, Chrome, Chromium, which runs on the Chrome notebooks, they'll all read FAT. You just store it in FAT, and you could take it to any one of those systems, and it'll read that file system. File systems can be very specific to the computer that you're using because the operating systems people, the people that made the OS, usually made the file system. And not true with Linux, but it is for Windows and Mac. So that's the big thing to know. Any kind of FAT, I guess what I would say is, yeah, I've got a friend who has a Mac, and they wanted some of the pictures that we have from our trip. I want to make sure I can get that to him. You know, he wanted to be able to back them up. So I'm just going to get a little flash drive. I'll put them on there and give it to him. You would want to make sure that flash drive is formatted with, I would say, at least FAT32, if not exFAT. I would probably do exFAT. But basically, there's a lot of differences to what those mean and why, you know, what is really the difference between FAT32 and 64. And I'll explain that in another video if you're interested in watching that one. Now, the other stuff, this is Microsoft's newest one. They've been using it since the early 2000s. And so a lot of flash drives come formatted Ntfs, which is New Technology File System. It's much more robust. The main thing that you need to know is you're not going to just take an Ntfs formatted flash drive and put it in any system and have it work, because that's Microsoft's proprietary technology that really, honestly, you need to pay them for if you're going to read that stuff, right? So this allows file security. You can say you can not just read or not read only or anything like that. You can actually say James McBride is the only one that can open this file. It works differently than FAT. Most older Mac OS systems use an HFS plus. And what I mean by old, that would be 5 years or older. However, Macs have started using the Apple file system, APFS, which is much more robust. So what's happened with Ntfs is that they've had Ntfs version 1, 2, 3, 4, I think they're on 5 now. And so it's just called Ntfs, but there's actually different versions that keep expanding what the file system can do. Like, can I get a petabyte drive, which is a massive storage space? And yes, today you could, but back in Ntfs 3, you couldn't, right? So they kept the same name, but have different version numbers. Apple jumped from the old way of doing things to the new way of doing things. This is specifically much more designed to deal with flash storage instead of physical disk, spinning disk storage, and also can take zettabytes of data. And so you can have a ton of data there. Linux distributions will be on ext3 or 4. And then another one that's used is btree file system. So usually these days, if you're installing any version of Linux, it usually is going to be an ext4 version, and or this one. They'll usually give you an option. It's funny that they mentioned down here journaling. This is a feature I usually spend quite a bit of time on, journaling. Journaling helps to prevent data loss from crashes. So when we look at that, we go, okay, I don't see journaling. I see it here. So I guess ext3 is the only one that uses journaling? No. Ntfs has had journaling forever. HFS had journaling. The new Mac file system has journaling. This has journaling. This has journaling. Basically, when you don't journal what's happening, you have the potential to lose data massively. Journaling is the process of the system not only doing the copy, I'm copying this file to here, but keeping track of what it's doing at the time. And that's an important factor. So you're talking about it actually saying, okay, I've moved this bit, I moved that bit, I moved this bit, I moved that bit, I moved this bit, and it's tracking it. So think that you're copying a 200 gigabit file, and then the power goes off and shuts down your computer. What would happen if it wasn't keeping track of what it was doing at the time is likely corrupt your entire partition or volume for that. It would just screw it all up. And that's what would happen in Linux prior to ext3. And so if you dealt with Linux back then, they'd have all these different partitions. Instead of different folders to begin with, they have a bunch of different partitions. And that's because if you were copying something or it was writing something, and then power kicked off or something, that partition's gone. And at least the other partitions are good. Yay. Meanwhile, over on the Windows and Mac side, since the 90s, no problem. I mean, the early mid 80s. That's what I should say. In the mid 80s, no problem. If that happens on your computer, very rarely are you going to have an issue where it can't find the partition and you just totally destroyed your C drive by just one file getting messed up. That's something they realized early on. Most people still think that will happen. And obviously it's not good to go killing your computer or powering it off without letting it do its job. But you're a lot safer, and people don't usually never report, oh yeah, my power went off and now my hard drive is corrupted. But back in the early 80s, that was, yeah, that would have happened. As a matter of fact, most people would go through a process of parking their drive, and that would park the head away from the platter, just in case something happened, it wouldn't scratch up or mess up the platter. It was kind of a pain. So journaling is the process of saying, I was copying this file and I was at this portion of the copy. Another reason why that's important is there's all this stuff happening in the system, not just you copying files and moving files and renaming files, but the system is doing all this stuff. Oh, they changed their background. I've got to change this stuff, right? There's all these things that you don't know about that are going on. And if the power just shuts off during that process, it doesn't know where to pick up, what to do, what to flush and what to keep. And so journaling provides that ability to make sure that the system's going to boot back up and you didn't have any loss of data. For instance, in that process of copying the file, it'll come back up and go, oh, there's this copy process. Now I was halfway through this file. Trash both of that, right? So it trashes the information that was copied and it trashes the information that was going to be copied. All the other files are fine. It finished copying so many of them and didn't copy these. Still kind of a problem for us, right? We'd like AI to pick that up and go, hey, you were copying files and let me go ahead and finish that for you. Someday we'll get there. Could do it now, but they haven't done it yet. All right, and then file system features, like what can you do within the file system? Well, you can actually set things to compress. That was a huge deal back in the day when we had not enough storage space to go around. You could actually take a whole folder, put a check mark on it, on compression, and it would compress the folder. And then when you accessed it, it'd take a little longer to open that folder and show you the files, but you were good. Encryption is the process of converting information so that it cannot be understood without a key. So encryption is the process of basically taking that James McBride's most important text file and turning it into gibberish, unless you have the key to decode what it was or decrypt it. And so you can do that in operating systems and say, I want that encrypted, and it will encrypt it. You can add permissions. So can they get into this folder? Can they read that file? Journaling, already talked about that. And then size limitations. For instance, this happens all the time, and the error has gotten better on this. In the past, if you had, and this still happens to students, and they'll get this cryptic error, they've got this flash drive, and it's a 64 gig flash drive, and they formatted it FAT32. Well, FAT32 has a limitation on the file size of 4 gigs. So if you're, these days, if you were copying a video or an install of a really popular version of Linux, and it was 6 gigs, it would start to copy it and then it'd go, oh, there's a problem with this device. There's not enough free space. It would give the weird errors. So you need to know, don't use FAT32 unless it's on a smaller drive where you're never going to be able to even fit a 4 gig file on it. Otherwise, don't use it. Ntfs, right? Maximum file size. One file can be 16 exabytes. You haven't even gotten there yet. And then naming rules. Ntfs has got some really restrictive naming rules. You can't use forward slashes, backslashes, colons. All these are used within the system for certain things, and so they don't want you putting them into file names. ext, by contrast, it'll allow all the characters except for forward slash. And so if you name something on an ext4 partition, you can use most of the stuff, and then when you transfer it over to an NTFS partition, it'll go, I can't do it, or I'm going to rename it, something like that. File sharing means to actually allow another user to see that file and to use that file. And that can be done on a peer-to-peer network. It can be done on the same system, but file sharing is important. And people really don't think about this particular option. But being able to sit on my computer and work on a Word document and be able to have somebody else on a different computer work on the same Word document and not have file corruption took several years for the industry to get to that point, but that's a feature of the file system. Why it's fundamental to understand this stuff? Because I've seen student after student, I've seen tech person after tech person not understand that these features of what you can do are based on the file system. For instance, well, you can't do that. Well, why can't I do that 4 gigs? That's not like a big deal. Why can't I do it? Because you formatted it FAT32. That's why you can't do that. It's a limitation associated with the file system. It's an attribute that you can do because of the file system. You don't have that file system to do it. For instance, I mentioned FAT. You can't just click a check mark and have it compressed. You can't encrypt it. You can't deal with permissions. You can't do all that because it's all FAT instead of Ntfs or APFS or any of the others. Remember that these types of features come down to what you formatted it as. I formatted it this way. It's a EX FAT. That means I cannot put any permissions on it. That kind of thing.